Hokie dokie. This is going to be a 1014 quiz 2 review. I was lacking on the first week of class, and I forgot to make this because I was so focused on Gobbler Fest preparation and whatever. Anyway, I'm recording this now, so you have it. It's on file. It's recorded. It's uploaded. Whatever. For you special members, you will get an A members, and you will now get an A because I will have all the quiz reviews up, right? So this is going to be for the you will get an A or higher members, as it should be. And I'm basically just going to go through 15, 16 problems, something like that. And just so we have one cohesive review session to prepare you for quiz 2, okay? I'll start in just a moment, but let me write this out. What the heck is that? Let's get a color in here. All right, very good. Enjoy my shirt. That's a fun one. So it was my birthday about a week ago, and I just saw my mom. She got me a new chair. It's very Mojo Dojo Casa House. I don't really know what the hell to do with it, but thought I'd share that with you. That's pretty funny, right? It's alright. It's just like, it's like an upgraded lawn chair, like a camping chair, but it's leather. It's very strange. Alright, so I'm going to close this door. It feels a little weird. Alright. So I'm hoping to get through these problems relatively quickly. They're all pretty fast problems in general. Being from quiz 2, it's a lot of like introductory things with functions and domain and range, and it's mainly just like function based stuff. So defining a function is like a machine where you input something and the function has certain rules to it, or has a rule to it such that it outputs certain things dependent on what was input to it. Okay, so that's going to kind of determine, that's going to be kind of the idea behind functions. Domain is the set of inputs, and range is the set of outputs. Now, the lighting in here is so strange. I don't know why it's not amazing. Ooh, got a little desk light here. All right, let's just get into it. I'm going to go, where am I going to go? I'm going to open it so it's a little better here. Just check the audio. Where am I going to go? I'm going to open it so it's a little better here. Okay. I'm going to try to talk a little more clearly. Let's get started. Quiz 2 review sesh. Let's jump into it. 1014. Problem 1. Let's get started. They say, which of the graphs below represent a function? So the test we want to do here is known as the vertical line test. You might be familiar with it. It's basically saying if we kind of scan through graph A with a vertical line here, what we're checking for is, are there any two or more dots that are lying on the same vertical line? In other words, is there one x value that is creating two y values, or like one x value, 2 points on the same x value? I don't know. So as we scan through, that looks good. Oh wait, hold on. No, that's right. Hold up. So I'm trying to scan this. There we go. 1, 2, 3. Oh, those 2 points are right there. Yeah, so right here, see how those 2 points are on the same vertical line? That shows that graph A is not representing a function. The issue is there's one input, one x value input that is creating two outputs, and that is an issue. You can't have that with a function. So graph A is not a function. Now let's try graph B. Scanning through That looks good. That looks good. Good, 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 and good. So, because there are no, let me see. Because there are no 2 points that lie on the same vertical line on graph B, that's why graph B is considered a function. So only one output for every input, in other words. So graph B is a function, graph A is not. So only graph B represents a function. Again, that's the vertical line test. Let's go on to number 2. I had 2 examples here. Let's talk about it. They say the size of the class influences the student's satisfaction in a manner symbolized by the letter P. Which of the following function assertions accurately describes this relationship? So the main focus is size of the class. And let me start with that. So size of the class, and then the student's satisfaction. So you want to determine what the 2 variables are. You have size of the class, you have student satisfaction, and then you have this connector word between them. And in this case, that is influences. So the way I think about this is, because we're trying to set up like this information in an equation form and like a function representation form, I like to think about it as input, output, cause, and effect. So input is to cause as output is to effect. So we need to figure out what's the cause and what's the effect. So if they're saying the size of the class influences the student satisfaction, that means that the student satisfaction is dependent on the size of the class. And so size of the class is the cause, and the effect is the student's satisfaction. So synonymously, I think of cause as the input and the effect as the output. So, in other words, the size of the class is the input, and you should always see the input on the inside of parentheses. You should always see input inside parentheses. You should always see your letter right next to the input, but like outside the parentheses, and then your output is always just on the other side of the equation. So you're putting your input into the function P, and as a result, it spits out an output. Okay, so again, we want to see size of the class as the input, so we want to see size inside parentheses. So we can eliminate C and D because they don't have that, and then we want to see the output on the opposite side of the equation. So the output is the effect, which is the student's satisfaction. So we only see that in option A, so A is our answer. Okay, let's try one more. The class's average grade is influenced by the time of the course. So again, just focus on what the 2 main variables are. And then think about the word choice in between them, the connector word here, or phrase, influenced by. Little different than the last one. Last one was influences. This one is influenced by. So if the class's average grade is influenced by the time of the course, it flip-flops the cause and effect, because now if it's influenced by the time of the course, that means that this time of the course is the cause, and then the class's average grade is dependent on that cause, so it is the effect. And so naturally the cause is the input, the effect is the output. So the input, the time of the course, should be inside parentheses. If it's not, we get rid of it. We get rid of those options. And then the class's average grade is the output, so that should be on the opposite side of the equation from the input and the function, whatever. I hope that makes sense. Definitely play around with these. Try multiple versions of those. You'll see the words influences. You'll see influenced by. I think you'll see like depends on, whatever. Just get comfortable with understanding like what's the cause, what's the effect, likewise what's the input, what's the output. Put the input in parentheses. You got it. Okay, that was number 2. Let's do number 3. All right, I might not have blocked this out, so ignore this real quick. There we go. All right. Define f and g by f of v equals y and g of y equals v. Using the table below, which of the following is correct? So we have v values and y values, and they're asking, is f a function, or is g a function, or are both of them functions, or are neither of them functions? Here's how we do it. Starting with considering the function f of v. f of v equals y is telling us that f is a function where the v values are the inputs and the y values are the outputs. So what determines, or I guess how do we identify whether whether a relationship is a function or not? What we're going to check for is, are there any repeated input values? So to identify if f is a function, we want to ask ourselves, are there any repeated input values? In other words, repeated v values. So we scan across the v row here and we ask ourselves, are there any repeated values? 16, 3, 13, negative 18, 0, 11, 1, negative 11. I didn't see any repeated v values. So that's all we need to identify that f is a function. Because there are no repeated v values, because v are the input of f is a function. So f is good. I'll just say f, check. So now we check function g. Function g has inputs of y and outputs of v. So to identify whether g is a function, we need to scan through the inputs of the y values. We scan through the y values because they are the inputs of g. And we ask ourselves, are there any repeated y values? Negative 18, negative 2, 7, negative 4, negative 12, negative 9, 9, negative 1. I don't see any repeated values, which means because there are no repeated y values, there are no repeated inputs for the function g, which satisfies that g is a function. So in this case, I think both f and g are functions. Okay, so again, if any of these values were repeated, so let me give you an example since I didn't have one here. If we had y and v like this, if we saw a 9 and also a 9, and then we saw 11 and 1, this would be reason to say that g was not a function, because 9 repeats with 9. There's repeated input values. And that's like the simplified way of looking at it. The more conceptual way is this. Because there's a single y value, a single input of 9 that is producing two different outputs of v values of 11 and 1, that's the issue. You can't input a single 9 and get two outputs of 11 and 1. That just doesn't make sense. Imagine if you graph them. If you graph those two ordered pairs, 9, 11, and 9, 1, they'd be on the same vertical line. They'd fail the vertical line test, right? So that was number 2. So this was number 3. Thought I wrote it down. I guess not. All right, so that's a little background on functions in charts. This is number 4. Let's get cooking. They say if f is given by this function here, what is the output resulting from input equal to r plus v? Now, what they're telling you to do, what they're asking you to do, is take r plus v and input it in place of x. Substitute r plus v in place of x and then expand the whole thing. I do not encourage you to do this. I don't think you have to do this for these. I don't know why these are problems in this section. It's very dumb. Here's my approach. If you were to expand this, if you were to expand anything with x minus 5 cubed, that's equivalent to x minus 5 times x minus 5 times x minus 5. And regardless of whether you put an r plus v in place of every one of these x's, what stays the same? The minus 5s. Minus 5, minus 5, minus 5. If you multiply 3 negative 5s, like 3 minus 5s together, which you would eventually do, negative 5 times negative 5 times negative 5, what you would get is a negative 125. So my trick or my advice is just look for the answer with negative 125 in it and save yourself some time. And that'll be it. Okay? These are the hard versions of this problem. There might be other variations where you actually, might have to plug in the r plus v into whatever, but it'll be a more doable evaluation or expansion of whatever. So that is the process. The process is generally plug in the input they're giving you, expand it. Usually it's a little, like sometimes it can be a little bit easier than this, but if it's types like these, just do this number trick. Use the constant at the end, think about how many times it's being multiplied by itself, and then find that value at the end, okay? Think smarter, not harder. Okay, number 5, they say if f equals this function, then a value that is not in the domain of f is what? Okay, so the approach here is we're going to find an x value that makes the denominator equal to 0. Because any x value that would make the denominator equal to 0, anything divided by 0 is undefined. So if there's any x value that makes a denominator equal to 0, it's going to make the entire function value undefined, which is indicating that that x value that we plugged in just can't be in the domain, because the domain is the set of the x values or inputs that create defined function values. Okay, so 2 approaches. We could plug and chug these into the denominator to see which one gives us 0, or which one makes the denominator 0, or I'm going to go the factoring route. I'm going to set the denominator equal to 0 and factor it. So just to show you how that looks, we set the denominator equal to 0, and we're factoring. We have x, and we want to think about what are the 2 numbers that multiply to positive 3, but those 2 numbers add to negative 4. So you think about 3, what are the only factors of 3? 1 and 3. What variation, what signs of 1 and 3 would add to negative 4? Well, negative 4 is very negative, so we would need a negative 1 and a negative 3, because negative 1 times negative 3 is positive 3, but negative 1 plus negative 3, negative 4. Okay, so we have these factors, and then from these factors, if we set each of them equal to 0, and we solve for x, we add 1, so we get x equals 1, we add 3, we get x equals 3. We have our 2 solutions. We have our 2 x values that make the denominator equal to 0, which means these are the 2 x values that make the entire function. Come on, where's my pen? That make the entire function undefined. Therefore, these are the 2 x values that are not in the domain. Okay? Okay, so the only one we see here, excuse me, is x equals 3. And so we choose x equals 3, and we're done. Notice they don't have a 1 in the answer choices, but they do have a negative 1, and that's to throw you off. Make sure from these factors to get the correct solutions from those factors. So if you see x minus 1, the solution that comes from that factor is x equals 1. If you see x minus 3, the solution is x equals 3. If you saw x plus 1 in the factor, the solution would be negative 1. Okay? Okay. So again, alternate method is just like from the start, just plug these values into the denominator and see which x value gives you the denominator is equal to 0. Okay? That was number 5. Let's do number 6. Similar question, different function. Find the domain of this function. Now, there's no denominator that can somehow be equal to 0, but the restrictions on the domain are going to come from the square root in this case. What type of value can you not have underneath the square root? You can have positive numbers under square root. Can you have 0 under square root? Can you have negative numbers under square root? 0 is okay. You can have 0. You are allowed to have 0 underneath the square root. But negative numbers do not fly underneath a square root. They are no good. So what do we need to be true for square roots? We need everything underneath the square root to be either positive or 0. Everything underneath the square root has to be positive or 0 because it cannot be negative. So we set everything underneath the square root greater than or equal to 0. And then we solve this for x. So we subtract by 4. We get 10x is greater than or equal to negative 4. And we divide by 10. So we divide by 10, we get x is greater than or equal to negative 4/10, and then we reduce that fraction. We divide 4 and 10 by 2, and we get x is greater than or equal to negative 2/5, and that is option D. That's all there is to it. Anytime you see a square root, as long as the square root is not in the denominator, then you will set everything underneath the square root greater than or equal to 0 in order to find your domain restrictions, or just your domain, I guess. So x values have to be equal to or greater than negative 2/5 in order for there to not be negative values underneath the square root. Okay? Okay. If, I don't think y'all will have this, but if you were curious, if the square root was in the denominator, the only difference would be you still can't have negatives in the square root, but you also now would not be able to have a 0 in under the square root if that square root is in the denominator, only because you can't have zeros in the denominator. That creates undefined values as well. All right, that was number 7. That was number 6. This is number 7. Goodness gracious. All right. Assume that the ends of the graph extend, which of the following values is not in the range of y equals f of x. So assuming this graph extends, it's going down to the left, down to the right, forever. So we can take for granted, we can make the educated assumption that the maximum value, the highest value this graph will attain is y equals 1. It's passing through y equals 1 right there, right? But it's not going to hit any y values that are above y equals 1. So they say which of the following values is not in the range. Again, the range is the outputs. The range is the y values. So a value that's greater than 1, a value that this function will never hit, is y equals 4. Again, you're considering all these are y values, right? So the y value that will never be hit by this function is anything that's greater than 1. It will never hit 2, 3, 4, 5, and upward. But it will hit all these negative numbers. So that's why we eliminate B through D. Okay? Should be as simple as that. Let's keep going. This is number 8. They say, which of the following graphs is the graph of this function here? Negative x cubed minus 6. So you can take a couple different approaches here. I might start with the y-intercept approach. So the y-intercept approach is plug in x equals 0, and whatever result you get will be your y-intercept. Whatever y value you get, that'll be the y-intercept for the function. So if you plug in 0, you get negative 0 cubed. Anything with just 0 is just going to go to 0. So 0 minus 6. You have 0 minus 6, which is just negative 6. So negative 6 should be your y-intercept. So do we see any graphs with a y-intercept of negative 6? A looks good. B looks good. C does not look good. That's positive 6. And D does not look good. That is also positive 6. So just like that, we've narrowed it down to A and B. And then you could always take a couple different approaches. You could plug in an x value, say like 2 or negative 2. So like let's say we plugged in x equals 2. So if we plug in x equals 2 into the function, we get negative 2 cubed minus 6, which is negative 8 minus 6. So what this is telling us is that at x equals 2, the f value should be negative 14. So in other words, we should have an ordered pair 2, negative 14. 2, negative 14. So when we look at graph A, we have 2 and maybe a y value also of 2. So that's not any good, right? When we look at graph B, when the x value is 2, the y value is exactly negative 14. So the method would probably just be to plug in x equals 2 and get whatever the y value is from the function, whatever the f value is, and find that graph that has that ordered pair, 2 comma whatever. Okay? Okay. So that's graph B. Again, the y-intercept thing is helpful in general, like if you just want to know that. But I think just doing the plug-in 2 method is probably most efficient. Like it'll get you the answer every time right away. So, yeah. Number 9. I want to say we can use that method here too. So are these the same? Yeah, these are the same problem. Okay. So I'm going to try the 2 method. I'm going to plug in 2 into this function, see what y value we get, and just identify the function based on that. Okay. So 2 minus 2, 2 to the 4th. 2 was a funny number to plug in given this function with all the other 2's. But I've just plugged in a 2 in place of the x. Okay. So I'm evaluating this. We have 2 minus 2. I need to do 2 to the 4th first, which is 16. 2 times 2 times 2 times 2. And then we do 2 times 16, which is 32. And then we do 2 minus 32, which is negative 30. So the y value, or the f value, when x equals 2 is negative 30. So we look at these graphs and we ask ourselves, at 2, do we have negative 30? That's looking pretty good. At 2, do we have negative 30? We do not. Not on that one. At 2, do we have negative 30? No, that's positive 10. And at 2, do we have negative 30? No, that's negative 6. So, just using the 2 method, the x equals 2 method, we get the y value of negative 30, and that only shows up in option A. Okay? Okay, that's a fun one. Let's go on to number 10. All right, doing pretty good on time. I'm just trying to get through these next like 5 or 6 problems and wrap it up for a little 30-ish, 40-ish minute session, just so it's recorded and uploaded. But as always, if you have any questions, let me know. All right, let's keep going. A bacteria culture is being examined as it grows. During the first 5 days, the culture count increases from 7,171 to 8,323. Unfortunately, they have a contaminant, and so the bacteria only increases by 383 over the next 5 days. They ask, what is the average rate of increase for the entire observation period? So, first step, maybe figure out how long the entire observation period is. They say during the first 5 days, but then later on they say over the next 5 days. It's usually not 5 and 5. It might be like 4 and then 7, or like 2 and then 5, like whatever. But it just happens to be 5 and 5. So 5 plus 5 is 10 days. They are asking us, what is the average rate of increase over that entire 10 days from start to finish? What is the average rate of increase? The biggest thing is probably this. The average rate of increase. Anytime you see the phrase average rate of change or average rate of increase or decrease, whatever, average rate is just a fancy phrase for the slope. Okay? It just means find the slope over the entire observation period or the entire 10 days. Okay? So, what do? How do we find slope? We need 2 points. If we want to find slope, we need 2 points. We need an x1, y1, and we need an x2 and a y2. So x1 and y1 would be, well, at the start of the observation period, the t value, the time, is 0. And the starting bacteria, the first population, like culture count that we see, is the 7,000 value. So 7171. That's our starting population at day 0. Over the first 5 days, it grows to that 8,323, but then that's only the population at day 5. So then over the next 5 days, it grows an extra 383. So that means by the end of the observation period, by day 10, it has grown not just to 8,323, but it's grown the additional 383 on top of that. So calculating this, this sum is how we get the second y value. So 8323 plus 383.
The answer is 8,706.
8,706. Okay. 8,706. So what we have are two ordered pairs now. We have an x1 and a y1, x2 and a y2. So we find the slope. Find the change in y values, y2 minus y1, and we divide it by x2 minus x1. 8706 minus 7171.
Whose contact info are you looking for?
Nope. Let's try that again. 8,706 minus 7,171.
Whose contact info are you looking for?
All right. I really thought that would work. Why did that not work? Let's try one of my phones here. What the heck? 8,706 minus 7,171. All right, my iPhones are breaking here. Nothing's working. All right, this should not be this hard. Give me one sec. This is stupid. 8706 minus 7171. Okay. Cheese and crackers. Why did that take so much time? Okay, so we have 1535 divided by 10. If we divide this by 10, we're just going to get something that looks very similar. It's going to be 153.5, and that is bacteria per day. So that is option B. And that's it. So you find the slope between the start and end values, and that's pretty much it. So you just find a starting point, end point, find the slope between them. All right. That was number 10. Let's do number 11. They tell us that the average rate of change of a function on some interval is -1. Again, average rate of change just means slope. They're telling us that the slope of one of these functions from 1 to 3 is -1. What is that? What does that mean? That means if we put a dot on one of these functions, if we put dots at 1 and at 3, and we connected these two lines, that line should have a slope of -1, and we are trying to find which graph has that slope of -1 between 1 and 3. Okay, so I might kind of do this for all these here. I might just find the slope, but I think I'm going to find the slope in a very rise over run sort of manner here to keep it simple. So instead of like finding two ordered pairs and then doing the formula, I'm going to treat it as, if we're starting here, if we go down 1 and we go down 2 and we go down 3, and then we go, so we go down 3 and we go over 1 and 2. So we go down 3 and over 2. That means we are rising -3 because we went down 3 and over 2. This is rise over run. This is a method of finding slope. Hopefully it sounds familiar. Rise over run in this case is 3 over 2, -3 over 2. This is not equal to -1. It's about equal to -1.5. It is equal to -1.5. It's not equal to -1. So the slope between 1 and 3 here is not -1. All right, let's do B. Put a point at x equals 1 and at x equals 3. Rise over run, we go down 1 and 2, so -2, and we go across, or we run 1 and 2. Okay, so it looks like we have -2 over 2. That does equal -1. B might be our answer. Let's keep going. Actually, I can tell you right away. What do you notice about these slopes between 1 and 3 and 1 and 3? If we did rise over run, would we be rising or would we be falling? I don't know. The opposite would we be rising positively or negatively? We'd be rising positively. What I'm trying to say is these graphs are increasing. They have a positive slope. They have a positive increasing behavior, whatever. These would all have positive slopes between 1 and 3. So we could have eliminated those right off the bat if we're looking for a slope of -1, right? So anyway, just find the slope between x equals 1 and x equals 3. See if it equals what they're looking for. Okay. That was number 11. Here's number 12. They say determine the values of m and b for the linear function. So they've given us the function in a weird format. What we have to do is expand it, simplify it, whatever, combine like terms, and hopefully get it in the form of y equals mx plus b, or f of x equals mx plus b, okay? So we're just starting with this here. First thing we could do is probably distribute this 3 to the minus 7x and the minus 5. So 3 times negative 7x is negative 21x. 3 times negative 5 is negative 15. Then we have the plus 3x over 2 plus 6. So we're getting close here. We just want to combine the like terms, the two x terms, and then eventually the numbers. So I'm going to start with, how do I want to do this? I'm going to keep everything fractions. I'm going to avoid decimals as best I can. So since this fraction has 3 over 2, I want to convert this fraction so that it also has a 2 in the denominator. Currently, it's negative 21 over 1 if we wrote it as a fraction. But if we multiply the 1 by a 2 to get 2, and we did to the denominator, or did to the numerator what we did to the denominator, and multiply 21 by 2, we would also get 42. So we've converted negative 21 to a fraction with a denominator of 2. That's negative 42 over 2. And we tack on the x. Now we can combine the 3 over 2, x, and then I'll go ahead and say that negative 15 plus 6, what is that? That's 9, negative 9. So we have minus 9 on the end there. Now we combine the fractions. Negative 42 plus 3 is negative 39. We leave it over 2, we leave the x, we subtract the 9, and that's what we're looking for. So our m, keep in mind this is in the form of mx plus b. Now we have a coefficient times x and then a constant next to the x, so the b. So anyway, we have negative 39 over 2 and negative 9. We're looking for option A, and that's all there is to it. All right. That was number 12. Let's do number 13. They say you have been given $2 today, day 0, and promised an additional $3 every day for 5 days. Which of the following graphs represents the money you would have as a function of number of days d? Okay, so you're starting with $2 at day 0. That means at day 0, at x equals 0, or d equals 0, your y value should be 2. Your y-intercept on this graph should be 2. Can we eliminate any graphs based on that? It looks like A has a y-intercept of 2. B has a y-intercept of 3. So I'm going to go ahead and throw that away. Looks like C has a y-intercept of 1. Let's throw it away. D has a y-intercept of 2. So we're between A and D, it looks like. And then they promised $3 every day for 5 days. So $3 a day. What that means is your slope should be 3. Your y value should go up by 3 every time you go 1 across. So for every day, every horizontal increase, your y value should go up by 3. That's what we want to look for. So if the start, day 0, you had $2, that means by day 1, you should have increased that $2 by $3 to get to $5. So at 1, we should have a point at $5. Then at day 2, it should be up to $8. Well, these points are not lying on this line at all. How about on option D? Look at this. Day 1, $5. It's increased $3 from the 2 we had at day 0 to 5 at day 1 to 8 roughly at day 2. 8 plus 3 is 11. We have 11 at day 3 and so on. So D is the best choice here. It's increasing by $3 a day, whereas A did start at 2, but it's not increasing at the right slope. Okay? So we eliminate that, get a good look at all that. All right, that was 13. Here is number 14. All the graphs below appear to be straight lines. Using the 3 points shown on the graph, which one could represent a linear function? To be a linear function, the line, the graph, should have a constant slope. The same slope or the same rate of change the entire time. So the approach is find the slope between points 1 and 2. Next, find the slope between points 2 and 3. So find the slope of the first segment, slope of the second segment, and we want to see, are the two slopes equal? There's only one graph here where the two slopes will be equal to one another. So I'll demonstrate it with A, and then we'll kind of, I'll just keep going through. Obviously, I'm demonstrating it for the whole thing. Okay. Slope between 1 and 2. I think in terms of rise and run, again, if you preferred it, you could do finding the two ordered pairs. So find the ordered pair at point 1, find the ordered pair at point 2, do y2 minus y1 over x2 minus x1 to find slope. It's very time consuming in my opinion. So I prefer rise over run, just dealing with it graphically and just kind of counting whatever. So the rise over run between 1 and 2, you are rising from 27 to 37. That's 10. And you are running from 6 to 8. So 2. 10 divided by 2, that's rise over run, is 5. That's our slope between points 1 and 2. Now, the slope between 2 and 3, we are rising from 37 to 43. That's 6. And we are running from 8 to 9. That's 1. So does 5 equal 6 over 1? It does not. 5 does not equal 6. So we eliminate A and we keep it pushing. So real quick here, 7 to 10 is 3. 6 to 8 is 2. So we get 3 over 2 for the first one. And then from 10 to 12 is a rise of 2. 8 to 9 is a run of 1. So we get 2 over 1. Does 3 over 2 equal 2 over 1? Nope. 1.5 does not equal 2. So we keep it pushing. Rise of 6 from 21 to 27. Run of 2. 6 over 2 is 3. How about this? Rise of 3. Run of 1. Does 3 equal 3 over 1? Yes. And I'll just do option D just to confirm. We rise from 11 to 17. That's 6. We run 2. So 2. 6 over 2 is 3. And then we rise from 17 to 19. That's 2. 8 to 9 is 1. So does 3 equal 2 over 1? Nope. And so C is our answer. C is a graph of a linear function because it has a constant slope the entire time. The slope of segment 1 and segment 2 were equal to one another. All right, that was 14. Let's do, I think I have more. Do I not have more? That might be it. No way. I could have swore I had more. Thought I had like 15 or 16 problems. Okay. I think I had 16 pictures and then they were blended with the others. Okay, cool. All right, that was it. All right, great stuff. Great stuff. We covered a lot. Covered what it means to be a function, what it means to be not a function, a little bit on domain and range, a little bit on slope or average rate of change. We did a lot. This is good stuff. I love it. Okay. I'm just going to scroll through the little bit of work we did today. Again, hopefully no one who had this membership was hoping for this quiz review on the very first week. But if you were, I'm sorry. Here it is. Hopefully you can utilize this to study for your exam. That is this week. If you have any questions, as always, hit me up. And my email should be in the description of this live stream, of this video. It's carterdeeemath@gmail.com. Going forward, I'm going to try to have a regular schedule for these review sessions, so look out for information on that, I guess. And in general, send me questions that you want to see worked out. These review sessions are meant for me to work out problems that you all have. But if you don't send problems, then I'm just assuming these videos are good. These videos are all you need. Maybe they're working. But if you have specific questions, send them my way. I can work them out in the next review session, or I can just, help you. I can email you back. and provide some solutions or whatever. Okay, thank you so much. I will see you all sometime later this week in like a day or two for the exam review. Okay, very good. Bye-bye.